What's important is that you will use fractions also, and the restriction was x should be more than equal than 0. Now, x is just more than 0. Why? Because of ln. So if you set up your table now, there are x and y. So what is ln 0.25? That's where we will start. A quarter there. Is it here? And then, for instance, a half. And then you can go to 1, 0. No, x should not be 0. Yeah, 3/4, but then you can get to 1, 1 1/4, 1.25. That's how we will go. And then, now remember, if we look here at the graph, where will the y-intercept be?
3.
At 3. Can you see? At 3. That's where we, so that's still our, so that means this graph is now not going to cut here, but it will move up. Yeah, x is 1. That's right. It could be. And y is, yeah. Sorry. This is the inverse function of e. So this one will cut here. It will cut the y-axis, isn't it? So the x-axis. So this graph looks something like this, isn't it? So remember to draw your arrows. Remember to show asymptotes getting closer and closer to 0, but you will not cut it. Now here's now an extra thing. We have to draw this line, that asymptote line. You have to indicate it because they want to see it. Where is this line going to be? Here at 3. At 3. It will there be at 3. And where will it cut here? What is this point that it cuts here? The asymptote is that line which it will not cut. Usually it's the y-axis, but now because there's a +3, it moves a little bit away. So the asymptote line is that 3 there. Usually it was 1. Usually it's 1, but now because there's a 3, the asymptote line will be at 3 there. It will there be at 3. And what is this point where it cuts the axis? Because they need to see those coordinates. 0. When do we get that point? If x is 0. So if x is 0 here, what is this one? 3. No, this is the other way around. Sorry, I'm wrong now here. It will be 3, 0. Yeah, but if that will just fall away then there, because it's more than that. That's right. There. That's the asymptote line. No, but this will be the asymptote line. It will lie there at that point. It will be there. So here you have, mine is crossing it, but it shouldn't. Okay, and then they say find an expression for f gx. So f gx, this is easy. G goes into f. So it is then 1 over 3 plus ln x minus 1. And don't leave it like that, but they want the final answer. 1 is equal to 2 plus ln x. Very easy. Then explain why ff2 cannot be evaluated. Now, what did we say is ff2? Yeah, or the square, I just do the same thing. F is 1 over, so it is then 1 over 2 minus 1, which is 1. Then you again f that 1. So it's 1 over 1 minus 1. But refer to the restriction, x should be more than 0. So you refer back to that restriction there. And then find an expression for the inverse function. So now we're working with that original one. Y is equal to 3 plus ln x. I showed you this yesterday. How do we get inverse functions? You still swap x and y. So x is equal to 3 plus ln y. What would be your next step, Albert? X minus 3 is equal to ln y. In the previous question, you will remember we took the 1 over in the last step, but it was in brackets. This time the 3 stands alone. It's not part of ln. If you just look there at question 6, it was ln and then in brackets x plus 1. So that's why the 1 came over in a final step. Here, we take it over first, and then how do you write y now? E to the power of x minus 3. So now 3 is there. 3 is an index, and we have to write g negative 1x. And then using different axes, sketch now the inverse one. Write the coordinates of any point of intersection with the axis. So you had to draw it on a different one. I'm going to draw mine now on the same one. But you can draw it on a different one, isn't it? No, but yeah, this is what I'm saying. But they say draw it on a different one. I don't know why. That's what they say. But I'm just going to do it here because then you can see it. So it should now be the reflection of this one. Can you see? In this line. So you can still set a table, choose a scale, or you can reverse this table. Then you will also get those values. This is how it will look like. And then again, we draw that line of the asymptotes. You have to draw that line of the asymptotes there at 3. Okay, and then the last question is write the coordinates here of the point of intersection. So what is this point of intersection? Near 0, 3 this time. Usually it's 0, 1, but now because we have a C, it moves up. I don't know what I have to say anymore. If you have an original graph, this one, y is equal to ex. Then we said this one cuts here at 0, 1. So the asymptote line will lie there. Yeah. And if you draw the inverse, it looks like this. So then we also have an asymptote line there. So there's also always this asymptote line. And it's 1 because it cuts there, because e to the power of 0 is 1. So it will move further then from that one then there. Yeah, I just didn't draw it now nicely, but that's what we're going to do. Yes, yes.